So hi. So இன்னைக்கு ஆக்சுவலாக வந்து நம்ம என்ன பார்க்க போகிறோம் அப்படின்னா Einstein's photoelectric equation. So இதுக்கு முன்னாடி வந்து we were discussing on experimental study on photoelectric effect, right? So அதில் நம்ம என்ன பார்த்தோம், effect of intensity, effect of potential difference and effect of frequencies அப்படின்னு பார்த்து அதுக்கு ரெஸ்பெக்டிவ் கிராஃப்ஸ் எல்லாமே வரைஞ்சிருந்தோம். And we also experimentally proved how it is going to affect on photoelectric current. Okay, right. So in this case, Einstein's photoelectric equation is the next step of photoelectric effect. So what actually Einstein does is, so he takes a metal surface. Okay, so he is going to pass, say, UV light. So basically photoelectric effect is nothing but what? By applying light source, you are going to knock off the electrons out of the surface of a metal, right? Okay, so ultimately the ultraviolet light which is going to be passed is going to be packets of photons, right? So you know pretty well E is equal to h nu. It is nothing but energy of a photon. Yes or no? Right? Yes. So whenever a UV light is being passed on the surface of a metal, okay, so what will happen? The electrons will get knocked off. Correct? So the electrons are getting knocked off. After that, what happens? The knocked off electrons are going to travel, yes, with some energy. So the amount of energy which is passed on to the surface of the metal is going to split into two. Number one, first part of the energy is going to be utilized for work function of the metal, which means what? The energy which is required to knock off the electrons out. Okay, so one part of E is equal to h nu is going to be used for that. The other part of E is equal to h nu is going to be used for the kinetic energy of the electrons which is being knocked off. Because when the electrons are coming out, obviously it is not going to be static. It is going to move. Yes, so on which part of energy it is going to move? The energy which is given as incident. Yes or no? So அப்போ நான் கொடுக்கிற இந்த UV rays ஆன energy which is E is equal to h nu is going to split into the work function and the kinetic energy of the electron. So half mv square max. Right? So this is how the energy is going to be splitted up. Okay? So based on this, so W naught is nothing but the work function which can be written like h nu naught, where nu naught is going to be the threshold frequency. Correct. So W naught into the work function which is nothing but the minimum energy required to knock off the electrons out of the surface of a metal. So but W naught is going to be h nu naught. Yes, and this is going to be the kinetic energy with which the electrons are going to move after exciting out of the surface of the metal. Clear? Right. So from this, can I take, so h nu is equal to h nu naught plus kinetic energy, so which is nothing but maximum kinetic energy. So the kinetic energy can be written like h nu minus h nu naught. Basically the kinetic energy which we were discussing in the terms of effect of potential difference and effect of frequency was considered as what? K is equal to EV naught. Yes, so can I replace that here? So what happens? EV naught will be equal to h nu naught, where h common, nu minus nu naught is equal to EV naught. Okay, so this is nothing but what? The kinetic energy which is being developed. Okay, so this equation is basically called as Einstein's photoelectric equation, or otherwise this both are same only. Okay, right? So the kinetic energy of the electrons which is knocked off is going to be what? H nu minus h nu naught, or h into nu minus nu naught. Is that clear? Right? Okay, and then so now we know k is equal to EV naught is equal to h into nu minus nu naught. So from this we can also calculate what is going to be the stopping potential. Right? So V naught can be done like h by E into nu minus nu naught. Correct? Yes? Right. So from this we can also write this h nu naught when you are bringing it inside, h nu by E minus h nu naught by E. So h nu by E minus work function divided by E is nothing but V naught. Right? So when you are drawing a graph stating with respect to nu and V naught, nu and V naught, so what you will get, see this, this is nothing but V naught, which can be like h by E times nu minus work function by E. So can I relate this with respect to Y is equal to mx plus C formula? Why am I doing this? X is going to be frequency. Y is going to be stopping potential. So the coefficients are going to be m, which is nothing but the slope. Yes. So slope is nothing but what? H by E. And work function by magnitude of charge. Both are going to be constant always, because work function depends on the metal. Over metal over work function rukma, that is constant. E is magnitude of charge, so constant. So can I relate this with Y is equal to mx plus C? So what will be the graph? So it will be like this, right? Maybe here. So in this case, what will be the slope? H by E, because the slope is H by E, right? Yes. So this is nothing but going to be work function by E, which is nothing but W is equal to EV naught only. Correct? So kinetic energy தான் நம்ம வந்து ஆப்போசிட்டா ஸ்டாப்பிங் பொட்டன்ஷியலுக்கு எவ்வளவு கொடுக்குறோமோ அதுக்கேற்ற மாதிரி ஸ்டாப் ஆகும் நம்ம பார்த்தோம். கரெக்ட்டா? So it is going to be the same. So this is going to be a straight line graph. So Einstein's photoelectric equation பொறுத்த வரைக்கும் the frequency and the stopping potential are going to be linearly decreasing function. நான் உங்களுக்கு முன்னாடியே சொல்லியிருந்தேன், நம்ம ஈவன் எஃபெக்ட் ஆஃப் ஃப்ரீக்வன்சிலே கூட பார்த்துருந்தோம். ஸோ த்ரெஷோல்டு ஃப்ரீக்வன்சிஸ் வில் வேரி பேஸ்ட் ஆன் தி ஸ்டாப்பிங் பொட்டன்ஷியல்ஸ் அப்படின்னு பார்த்தோம். Because when the frequency increases, the kinetic energy increases. When the kinetic energy increases, the stopping potential increases. Correct? So obviously they are going to be linear when we are considering stopping potential and frequency. In that case, we didn't consider the frequency and stopping potential. We considered what? One particular intensity of light fixed. கரெக்டா? அப்புறம் நம்ம என்ன பார்த்தோம்? டிஃப்ரெண்ட் ஃப்ரீக்வன்சிஸ்க்கு எந்தெந்த இடத்துல உங்களுக்கு ஸ்டாப்பிங் பொட்டன்ஷியல்ஸ் இருக்குன்னு பார்க்கும்போது இட் வாஸ் ப்ரொபோஷனல். ஸோ ப்ரொபோஷனல் அப்படின்னா ஸ்ட்ரெயிட் லைனாக தானே இருக்கணும். எஸ். ஸோ த ஈக்குவேஷன் இஸ் கோயிங் டு பி what? H by E nu minus W naught by E. So this is nothing but the stopping potentials equation. The respective graph is going to be like that. Okay, so this is going to hold good for any kind of metal. Is that clear? Right? Yes. And from this again you can take theta. So what is going to be the theta? So tan theta is going to be what? Again slope dana. கரெக்டாப்பா? ஸோ எந்த ஆங்கிளில் வருது அப்படிங்கிறத நீங்கள் tan theta வச்சே கண்டுபிடிச்சிடலாமா? ஸ்லோப்னாலும் tan theta தானே? எஸ் ஆர் நோ? கிராஃபில் ஸ்லோப் இஸ் நத்திங் பட் வாட்? டான்ஜென்ஷியல் ஆங்கிள் தான். ஆப்போசிட் பை அட்ஜசென்ட். y by x. சிம்பிள். இஸ் தட் கிளியர்? ரைட்? ஏதாவது டவுட்ஸ் இருக்கா இது வரைக்கும்? ஸோ ஐன்ஸ்டீன் என்ன சொல்கிறாரு? நான் அனுப்புகிற எனர்ஜி ஆஃப் ஃபோட்டான்ஸு அதோட எனர்ஜியை எப்படி யூஸ் பண்ணுது அப்படின்னா, ஒரு பார்ட் ஆஃப் எனர்ஜியை ஒர்க் ஃபங்க்ஷனாக வச்சு எலக்ட்ரான்ஸை வெளில அனுப்புது. பேலன்ஸ் இருக்க எனர்ஜி வெளில வந்த எலக்ட்ரான்ஸுக்கு ஒரு கைனடிக் எனர்ஜியாக கன்வெர்ட் ஆகுது. ஸோ திஸ் இஸ் ஹவு த இன்சிடென்ட் ஃபோட்டான்ஸ் ஆர் இன்சிடென்ட் லைட்ஸ் எனர்ஜி இஸ் பீயிங் யூட்டிலைஸ்ட். Is that clear? So this is what is Einstein's photoelectric equation.